In the last video, we have we saw that when we were differentiating with respect to dwlk, this summation uh, got uh, disappeared, and only ak3 is remaining. And this is how it was done. Uh, Here, it is WLK, that is weight from the kth unit to the lth unit, and we would want to differentiate it uh, with this ZLK. We want to differentiate ZLK with respect to WLK, and the ZLK is obtained from the summation of all, all the weights and the corresponding multiplication of A3. Then we get ZL. Therefore, WLK, when we will differentiate it with all the multiplication of A3 and W's, this A3 and W and this W, we will only get uh, uh, some differentiation equals to 1 when we will differentiate this WLK with respect to itself, and we will get 1. And since it is WLK was multiplied with uh, AK3, we get AK3 as our let. All the other weights, as they are constant with respect to WLK3, will be 0. So I hope that is clear. Let's move to the next slide. Yes, uh, now the fourth step is finding the derivative of cos j w comma b with respect to z3. Uh, Here, therefore, we are finding the derivative of cost function with respect to z3, which is calculated from this node. Yes, which is calculated from this node, and we can see that the influence of z3 is over all the units in this layer, and therefore the summation sign will not be gone. See, we have our cost function as summation over L equals to 1 of over error square uh, for k equals to 1 to n3, that is for k equals to 1 to n3, dj by dk3 equals to summation over L to 1 to O, and this power is comes 0 and cancelled by 1 by 2, and hence we will get al4 minus ytl into applying the chain rule, dal4 by dk dzk. Notice here that the summation sign is not gone. dj by dzk is equals to summation over L equals to 1 to O al4 minus ytl into, here we have substituted al4 with sigmoid of zl4. In the next step, uh, we applied the chain rule, and in place of dzk, we have replaced it with differentiation of sigmoid of zl4 with respect to zl4 into differentiation of zl4 with respect to dzk. In the next step, uh, this this term uh, this term is sigmoid of ZL4 into 1 minus sigmoid of ZL4, since it is the property of sigmoid function. And this term, we are expanding ZL4 from the equation we derived in the forward propagation, and ZL4 is equals to WLK3 into summation over k from k equals to 1 to n3, WLK3 into AK3 plus BL3. Uh, Therefore, let's move to the next step. Uh, Here we can see that uh, when we are differentiating zk3 with respect to this summation over k, that means we are respecting zk3 with respect to summation over uh, all the k's. We will all the k's will only get only the kth as our non-zero derivative. All the other zero all the other derivative with respect to zk will be zero, and only the kth term will have a non-zero derivative, and that will be, and the remaining will be wlk3 into dak3 by dzk3. AK3 will be substituted as sigmoid of ZK3. Now the sigmoid of ZK3 will become sigmoid of Z3, that is AK3, into 1 minus sigmoid of ZK3, that is AK3. Yeah. So finally the term will be this long term, and we were going to get it short. The next step, we have assumed that this long term, and we are going to make it short. See, we have assumed that this term, I mean this term, this whole term is denoted as dl4 from al4 minus ytl to 1 minus al4. This whole term is denoted as dl4. Don't get confused by this capital O. This capital O is over the summation. Not this is not the part of the inner content of the summation. Here also wlk3 it is here, and let's move to the next step. Since we are the summation is over L, and here the term is K, we can take these terms out, and we get AK3 into 1 minus AK3 into summation over L dl4 cross wlk3. And now we can see that uh, we have to finally we have got the term finally, but let's say we want to represent it as vectorially. Vectorially we can see that the equation is represented as dj by dz3 equals to a3 element was multiplication into 1 minus a3 element was multiplication of w3 transpose into cross d4. Dimensionality we can check. uh, a3 is n3 cross 1, w3 is n4 cross n3, and d4 is n4 cross 1. So the dimensionality will be uh, the a3 and 1 minus a3 whole element wise multiplication will result in a matrix of n3 cross 1, and w3 transpose will be n3 cross n4, and d4 is n4 cross 1. Therefore uh, the last term will become n3 cross 1. Yeah, n3 cross 1 element wise multiplication of n3 cross 1, and this will finally become n3 cross 1. Yeah. We assume that let's call dj by dz3 as capital D3, and dj by dzk3 as dk3. Now finding derivative of cos j with respect to w2 for j from 1 to n2, and for k from 1 to n3. Since in w2 there are n3 cross n2 elements, dj by dwk2 equals to dj by dzk3 into dzk3 by dwk2. I'm just applying the chain rule here. Now substituting the value of zk3, we will get summation over j to n2 wkj2 into aj2 plus bk2. This z this zk3 is substituted from the forward propagation equations. Also notice that j summation j in summation is different from the j in loop. Yeah, so j in this summation is different from the j in loop as it was in previous case. Now similarly as it was in previous case, this wkj will will have only the non-zero derivative with uh, the this wkj, and all the other j's will be zeroed out. Factorially, we can represent it as dj by dw2 is equals to d3 cross a2 transpose. We can see that the dimension of w2 is n3 cross n2, and dimension of d3 is n3 cross 1, and dimension of a3 is n2 cross 1. Therefore, n3 d3 is n3 cross 1, and a2 transpose is 1 cross n2. Therefore, d3 into a2 transpose will be n3 cross n2, and which has the same dimension as w3, that is n3 cross n2. Finding derivative of cost j w comma b with respect to w2. For k from 1 to n3, dj by dbk2 equals to dj by dk3 cross dk3 by dl3. Just applying the chain rule for here, since uh, there are n3 elements in b2. Therefore, uh, yeah, we iterate from k for k from 1 to n3, and we will be applying the chain rule. And here we have break the differentiation with respect to zk3. Again, this whole representation will be replaced as dk3, uh, and uh, and zk3 is substituted from the forward propagation as the summation. Here again we can see that here we can again see that um, uh, here the dbk, when it will be differentiated with respect to the summation, only bk will be a non-zero, and that is 1, and all the other k's will become 0, and this also term will become 0. Therefore we will get only 1. Therefore dj by dbk 2 is equals to just dk3. Factorially, dj by db2 is equals to d3. Simple. Finding derivative of cost j w comma b with respect to z2. This is somehow too long to proceed, so just bear with me. For j equals to 1 to n2, that is for j equals to 1 to n2, we are differentiating uh, this our cost function with respect to each element in this layer, and after applying the chain rule, this square will be cancelled out by this one half, and also this into dal4 by dz2 will be the rest term. Now substituting L AL4 by sigmoid of ZL4. Applying the chain rule and breaking with respect to ZL4, the sigmoid of ZL4 with respect to ZL4 will become obviously sigmoid of ZL4 1 minus sigmoid of ZL4, and ZL4 is itself is substituted with the forward propagation equations, that is in this summation. Now again we will differentiate all the elements in this summation with respect to dj2. uh, since BL3 is a constant, it will be 0. The differentiation with respect to dj2 will be 0, and each element ak3 is will be differentiated with the respect to dzj2. Here what we are doing, let's see visually. We are differentiating with respect to this term, and what we are differentiating, the summation of uh, this all these terms, and all these terms are actually nothing but uh, sorry, we are differentiating all these terms are nothing but they are each term is the summation of uh, the corresponding output of the previous layer and their corresponding weights that are connected to them. And therefore when we will differentiate it with this, we will have a summation, and each summation will have a differentiation with respect to this constant will be multiplied, and we will have differentiation with respect to all these ak3. Now ak3 will be displaced sorry, ak3 will be substituted as sigmoid of zk3. Yeah, these ak3 will be substituted as sigmoid of zk3. Again applying the chain rule and breaking with respect to zk3, the differentiation over sigmoid of zk3 with respect to zk3 and into zk3 by dzj2. This by the sigmoid property, this will get sigmoid of zk3 into 1 minus sigmoid of zk3, and this term we have substituted it with dl4. Now we yes, now the summation is k over all these elements. Let's see what comes out next. Here also zk3 will, is um, substituted as a forward propagation equation, and again we are applying the method and differentiating it with respect to dzj2. Now we can see that when we are uh, differentiating with respect to z2 and all the terms in this, that is uh, these all the this summation of all this multiplication into weight, this multiplication into weight, this multiplication into weight, uh, for a particular k, that is for particular k, we will get only this connection as differentiation of this connection as non-zero, and all the other connections from this layer to that kth element will be zero. Therefore this summation sign will be gone, and we will get uh, only wkj2 into differentiation of aj2 with respect to dzj2. Here I have substituted aj2 with sigmoid of zj2. Now we can simply differentiate zj2 sigmoid of zj2 with respect to zj2, and we lastly we get sigmoid of zj2 into 1 minus sigmoid of zj2. This is our whole expression. let's see how we can compress it. Z sigma J2 is AJ2 obviously, and we have substituted with that. Since the summation is over L and K, our J terms will be taken out of the summation. Therefore, we have taken out the jth terms, and all the summation are here. Uh, yeah, just yeah. Now let's see how vectorially we will write it. Uh, Vectorially, it will be represented as A3 in into element-wise multiplication of 1 minus L3 into element-wise multiplication of over all these matrix multiplication terms. Dimensionality check, we can see A3 is N2 cross 1, W3 is N4 cross N3, D4 is N4 cross 1, and W2 is N3 cross N2. Now dimension is it will be equal to N2 cross 1 element wise, N2 cross 1 element wise of N2 cross N3 cross N3 cross N3 cross N3 cross N4 cross N4 cross N1. Yeah, we can see that W2 is N2 cross N3. W2 transpose is N2 cross N3. A3 and element wise 1 minus A3. Here this curly brace shows that we have originally A3 was N3 cross 1, but by this curly braces we mean that this N3 cross 1 is concatenated N3 times column wise, so it will become N3 cross a matrix of N3 cross N3. Here it is N3 cross N3, and W3 transpose is N3 cross N4, and D4 is N4 cross 1. After multiplication, we will get all these three elements multiplication. We will get N2 cross N4 and cross N4 cross 1. Here N2 cross 1 we will get at the end. Yeah. So lastly, we will get, since these are all element wise multiplication, we will get N2 cross 1 as our final dimension vector. Let's call now dj by dz2 as dj by dz2, this term as d2, and dj by dzj2 as dj2. Finally, for I from 1 to n1 and for j from 1 to n2. Since w1 is of size n2 cross n1, we are differentiating cost j with respect to each element. Hence these are the two loops, and iterating from I to j, we can see that dj by dwji 1 equals to dj by dzj2 cross into djz2 dzj2 by dwkz, and here we just applied the chain rule. We have just substituting dzj2 uh, from the forward propagation equations. We get only as our this differentiation of wji will be 1, all the other terms in the summation will be 0, and hence the 1 into ai1 is ai1. Therefore we have gotten our each element uh, differentiation of dj with respect to each element w1, and that is dj2 cross ai1 for the weight ji. Vectorially we can say that dj by dw1 is equals to d2 cross a1 transpose. You can see by yourself that the dimensions are correct. W1 is n2 cross 1, therefore derivative of dj by dw1 should also be n2 cross 1, and d2 is n2 cross 1. D2 is n2 cross 1. Yeah, D2 is n2 cross 1, and A1 is n1 cross 1. D2 cross A1 transpose will be n2 cross 1 into 1 cross n1. That will be n2 cross n1, and that's the same as the dimension of W1. Also, A1 is xt. Yeah, that is our input. Finding derivative of cos jw comma b with respect to b1. For j from 1 to n2, dj by db1 dbj1 equals to dj by dj2 cross dj2 dzj2 by dbj. Here dj by dzj is substituted as dj2 into and also zj2 will be substituted from the uh, forward propagation equations. Therefore, we will get this when we will differentiate bj1 with respect to dbj1. Sorry, when we will differentiate bj1 with respect to bj1, we will get 1. Therefore, dj by dwj is equals to dj2 cross n1, that is only dj2. Vectorially, yeah, vectorially we can see that dj by dv1 equals to capital D2. Now, since we have all the derivatives with respect to all the weights, we can update the weights. Assuming that we are using gradient descent alpha as our learning rate, W1 will be equals to W1 minus alpha into and derivative of cost function with respect to W1, and that is W1 minus alpha into D2 cross xt transpose. Similarly, b1 equals to b1 minus alpha dj b1 equals to b1 minus alpha cross d2. Yes, w2 equals to w2 minus alpha cross dj by dw2 is equals to w2 minus alpha cross d3 cross a2 transpose. b2 is equals to b2 minus alpha into dj b2 equals to b2 minus alpha into d3, and similarly all the weights. Yeah, note, practically for a particular weight the derivative is calculated for each example parallelly and is summed up. After that the change is made in the weight. In general, WL for the lth layer, the weight will be updated as follows: WL equals to WL minus alpha into 1 by tree, that is the size of our training set, into uh, summation over t equals to 1 to t djt, that is differentiation of j, for example t, with respect to wl. Similarly for vl also. Thank you.